Welcome everybody. This is going to be our how to use quadratic formula to solve quadratic equations video. And I hope this is going to be helpful for those who are trying this out and trying to solve quadratic equations but running into situations where it doesn't work out so great. Okay, so let's begin with the first question. We're asked to solve for x squared plus 6x plus 5 equals 0. Try to solve for x. In this situation, we would say to ourselves, okay, well, can we factor? And when we're factoring, we're trying to find these two numbers that would multiply to 5. Try to find two numbers that multiply to 5. And those same numbers would add to 6. Well, you can figure out what numbers multiply to 5. Well, really it's 5 and 1. So 5 times 1 and 5 plus 1. So these numbers work out great. And so we set up our factors. Our numbers go here, plus 5, plus 1, x and x, right? And we can, if we want to check, we can distribute x squared plus x plus 5x is 6x, and then 5 times 1 is 5, so it works out okay. Then we would then set each factor equal to 0. Okay, and we get x equals -5. Subtract 1. X equals -1. So our roots in this case are going to be x equals -5 and x equals -1. That works out fantastic. But we sometimes run situations where things aren't so fantastic. Here, we're trying to solve for x, where x squared plus 6x plus 4 equals 0. All right, let's try to use our technique. Two numbers that multiply to 4 and add to 6. Okay, let's see now. Well, I know 2 times 2 is 4, but 2 plus 2 is not 6. 4 times 1 is 4, but 4 plus 1 is 6. So the mystery now is nothing works out. Nothing. So what do we do? Well, we have something that can help us out here. All right. So let's go to our formula. We have something called the quadratic formula. We run into a quadratic equation that cannot be solved by factoring. We can use the quadratic formula to help solve the equation. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And that's when we set the equation equal to ax squared plus bx plus c equals 0. That's a lot. It's a lot to take in. But it's a formula, all right? And if you've seen some of the other videos I have previously show something called completing the square, and it really comes from completing the square. If you want to check out and see the derivation of where it comes from, you can watch some of the previous videos that I did from last year. So definitely check them out. If you're looking for completing the square, those videos do exist, and there are applications for this also. Now, here we want to figure out, well, this seems kind of a weird looking formula with A, B, and C, right? So let's take a look at our steps. How to use quadratic formula to solve a quadratic equation. Step 1, set the equation equal to 0. Okay. It should be in the form of ax squared plus bx plus c equals 0. You might want to put that down underneath the original equation to help you identify a, b, and c. Because once you find the values, step 2 is find the values of a, b, and c. Numerical values. Not the x values. I mean, it's not, not looking to attach the x now, just the number multiplying x squared, the number multiplying x, and then the constant. You then plug the values into the formula. And then we combine and simplify the equation. We might have to simplify radicals, just to understand that might be something to do. Okay? Let's go back to our problem then. So let's write out our, I'm going to erase all this stuff here because it didn't work out. Let's write out, in this case, ax squared plus bx plus c equals 0. Now, the a value matches up here. Now you're saying there's no a value here. Well, there is. There's a 1. So a equals 1. Our b value equals 6. And our c value equals 4. That's how we do. And again, when you're first trying these out, you definitely want to put this equation ax squared plus bx plus c equals 0 underneath the original one, so that's easy to see. At some point, you may not need to, but if you use the wrong numbers, you get the wrong answer. Now for a formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug in. So x equals negative, I put in parentheses, 6, because that's what b is equal to, plus or minus the square root of 6 squared minus 4 times a is 1, oops, and c is 4. Let's extend this radical symbol, okay, all over 2 times 1. Okay. Now, we want to find this value here underneath the radical, right? And you can use the calculator. 6 squared is going to be 36. Minus 4 times 1 times 4 is 16. And that will give us 20. So we will get now x equals negative 6 plus or minus the square root of 20 all over 2. Now, when I say simplify, we have to simplify the radical as well, too, the square root in this case. Because the square root of 20, if it can be simplified, well, we want to see in this case what two numbers multiply to 20 where one of them is the biggest perfect square. I can divide into it, though. So we had a list of perfect squares, but it looks like in this case, the large perfect square that divides evenly to 20 is 4. And of course, well, when you divide 20 by 4, you get 5. To simplify square root of 20, becomes now the square root of 4 now becomes 2, and it's still multiplying the square root of 5, so it's 2 square root of 5. So our answer starts looking like this. X equals negative 6 plus or minus 2 square root of 5 over 2. Now, it looks like these numbers outside the radical all can be divided by the same thing. And really, this is what it looks like. Negative 6 over 2 plus or minus 2 square root of 5 over 2. Okay? And so this now becomes negative 3, because negative 6 over 2 is negative 3, and the 2's divide out for the second part, and we're left with square root of 5. So this means x is equal to negative 3 plus or minus the square root of 5, which really means the following. Negative 3 plus square root of 5, x equals negative 3 minus square root of 5. So your answer can be written in this form or this form. Okay, and I'll make this full page so you can see everything here. Okay. All right, so definitely review this and go over our steps here. I think the part that a lot of times the students have difficulty with is going to be the simplifying radicals. Now, we notice in this case that whenever I answer, if your roots in this case, if your roots contain radicals, then they will always be conjugates of each other. We had in this case x equals p plus square root of q, x equals p minus square root of q. Because the previous problem we had, I believe it was x equals neg 3, was it neg 3? I think it's neg 3, right? Nope, here we go. X equals neg 3, should be neg 3, sorry. X equals neg 3 plus square root of 5, x equals neg 3 minus square root of 5. Notice that they're basically the same numbers, the same exact numbers, except the only difference is going to be plus or minus. That means that's why they're conjugates of each other, okay? So if you have radicals in the answer, you always have, they're always conjugates of each other. So if you know one, you know the other because it's the same numbers except the opposite sign between them, okay? Let's try another one. Here we have solve for 2x squared minus 9x minus 5 equals 0. And in this case, we have ax squared plus bx plus c equals 0. And now we move a little faster here. A equals 2, b equals negative 9, and c equals negative 5. Okay, now use our formula. X is equal to negative 9 plus or minus, that's the b value, negative 9 squared minus 4 times 2 times negative 5 all over 2 times 2. Negative 9 becomes positive 9. And now if this number here, 9 squared is 81 minus 4 times 2 is 8 times negative 5 is negative 40. Which means 81 minus negative 40 is the same as 81 plus 40, which is 121. So you get the square root of 121 all over 4. Now, what does this mean? Square root of 121 can be simplified though. The square root of 121 is equal to 11. So this now becomes 9 plus or minus 11 over 4. Okay, we can't leave it this way though. We do want to separate them. So we have x is equal to 9 plus 11 over 4, and x is equal to 9 minus 11 over 4. Okay, so 9 plus 11 over 4 is the same as 20 over 4, which is equal to 5. 9 minus 11 is neg 2 over 4, which means x equals a negative 1/2. So our roots here are x equals 5, x equals negative 1/2. And notice now, this answer didn't have radicals. I'll make this full page. This answer didn't have radicals. What does that mean? This quadratic equation could have been factored, but instead of factoring, we can use quadratic formula. We just have to simplify. So the quadratic formula will work, this page width, the quadratic formula will work on any quadratic equation, whether it can be factored or not. Okay? And so this is pretty important for us to understand. Okay, everybody? And this is we've done, in this case, we've done our quadratic formula lesson. Hopefully it's helpful to you guys. And if you like this video, if you find it helpful, give it a like and not subscribe to the channel yet, please do so. All right. I'll do more videos. Let me know, all right, in the comment section below. All right. And by the way, everyone, just be very careful about looking out for other videos, and this our raffle will be coming up pretty soon, probably within the year 2020 or 2021. We'll be running the raffle, okay, for those who are subscribed to the channel. All right, everybody, I will see you soon. Take care. Be safe.